Welcome to this presentation on C structures. You've learned that to store information as they execute, programs use variables. Each variable has a specific type, such as int, float, or double. Using an array, you can store multiple values of the same type within a variable. You might have an array of characters, an array of integers. But as your programs become more complex, there's going to be times where you're going to want to store values of different types in one variable. So you might have a student. A student has an age, they have a name, they have an email address, they have a phone number. Each one of these items can be a different data type, but we want to be able to combine them into one variable. In C, the structure allows us to do that. So let's go ahead and get started. So let's take a look at an example that kind of indicates why we need structures. In this case, we're going to have information about an employee. They're going to have an employee ID, a name, a job title, a salary, and a phone number. So we're keeping track of 5 different variables for each employee. We're going to have a function in this case called showEmployee. It receives all 5 of those parameters and just simply uses printf to display them to the screen. And so when we run this program, we see our employee ID, our name, our title, our salary, our phone number. All the information worked and we were able to create a working program. But it's cumbersome to keep track of those 5 different variables for each employee. That's where the struct comes into place. And so the keyword struct in C creates a data type that can contain multiple values but of different types. So you see in this case we're creating a struct called employee. It has an employee ID, type int, an employee name, an array of character strings, a job title, an array of character strings, a floating point salary, and an array of character strings to store a phone number. All of these values will be stored in one variable that we declare type employee. Let's take a look at how we do that. So here's our program. We're including standard io.h. It's got printf included. We're going to be using string.h layer because we're going to copy some contents into our character strings. But within main, we've got the keyword struct. We're specifying the structure that we're using, employee, and we're defining a variable. This is just the same as saying int count. We're saying struct employee, that's our data type, and our variable name is worker. Now, that created a variable of that structure type. And so we're going to print out the size of that variable. And so when we do, it says the size of worker is 552 bytes. Well, if we go back and take a look at our structure, we've got an int employee ID, we've got 256 bytes in the character string that contains the employee name, another 256 bytes. So if we add everything up, sure enough, we get to 552. So our one variable has got all these fields within it. And so C has to allocate enough memory to store that. So let's see how we take a look and use our actual structure. So here's our program. We're defining our structure again. Within main, we create a variable of that structure called worker. When you have a structure, you've got the different fields within that variable. And you need to be able to specify which field you want to assign the value from or use the value of. And to do that, you use the C dot operator. So you can see that we're saying worker.employee ID is equal to 1. That assigns the value 1 to that field within the structure. We're now using string copy to copy a name into the employee name. So you see we use worker.employee name. String copy to copy the title into the worker.job title. We can just assign directly the salary to worker.salary. And then we use string copy to copy a phone number into worker.phone. So the key point here is to start to understand that to access each field within a structure, we use the dot operator. You've learned that when you declare a variable, C allows you to initialize the variable at declaration. And a structure is no different. In this program, we're defining our structure employee with all of its fields. And within main, we create a variable called programmer of type structure employee, and we can initialize it by specifying the fields within left and right braces. And so we're creating our variable programmer. It's going to have the employee ID, 1, the employee name, Chris Jamesa, the employee.job title of programmer, the employee.salary of 100,000, and the employee.phone of 928-555-1212. And so let's go ahead and print one of those fields. Well, using printf, we'll print a character string, programmer.employee name. And we could print out the rest of the fields just for simplicity. I'm only printing one. Let's go ahead and run this. And sure enough, we see our character string. And so our structure is allowing us to store multiple values of different types. And we can initialize those when we create a structure variable. And so you've learned that you can pass variables to functions as parameters. And a variable type structure is no different. You can pass a structure variable to a function as a parameter. And so in this case, we've got a simple function. It's called showEmployee. You can see our parameter type is struct employee. That's what we're passing. And our local variable name is called worker. And so within the function, we're just printing out the different fields using the dot operator, the ID, the name, the title, the salary, the phone number. And so we use the dot operator to specify the corresponding fields. Within main, we're creating two variables of type struct. One is going to be the variable coder, which has information about Chris Jamesa, he's a programmer. The second is a variable called manager. It's got information about Debbie Jamesa, she's a manager. We're initializing both of those variables as we declare them, and then we're going to pass each one of those variables to showEmployee to show the corresponding fields. So let's go ahead and run this program. And sure enough, there's our two employees. And so in this case, we're not changing the values of the structure variables that we're passing to the functions. And so we just pass them by value. When we want to change one of the fields within a structure variable within a function, you'll see that we need to pass the structure variable by address. Just like we'd have to, if we wanted to change an integer variable, we'd have to pass that variable by address to a function. And so just keep in mind that structures are no different than any variable. We can pass them by value or we can pass them by reference. And so I wanted to take time to revisit the C standard library. We've actually used a function that returns a structure already. The div_t function allows us to divide a value and get the quotient and the remainder. And so we've used it. It's in standard lib.h, so including standard io.h and standard lib.h. And then we're creating a variable of type div_t. And div_t is defined as a structure. And so when we call the div function, it's going to, in this case, divide 20 by 7. And it's going to give us a quotient. And it's also going to give us a remainder. So let's go ahead and run this program. You can see that we're using the dot operator to get to each one of the fields. And sure enough, 20 divided by 7 is 2 remainder 6. That's right. And so in this case, we've had a function that returned a structure. And then we use that structure, the dot operator, within that structure to get to the specific fields. So we've already actually used code that uses structures. So we've learned that an array is a data type that allows us to store multiple values of the same type. Multiple values of type int, multiple values of type float. And a structure essentially is a data type, so we can create an array of structures. And so our program code is very similar to what we looked at so far. We've got our structure definition. We've got our function that receives a variable type structure, and we simply use the dot operator to display the corresponding fields. But within main, rather than creating two variables, we're now creating an array. And we're using the structure employee to create an array called staff. It's got two elements. And we're actually initializing those elements at declaration. So you can see that because we've got an array, we've got two sets of braces. Outer brace to define an array element, and then the inner braces that are defining each one of the array members. Once we've initialized our array, we can use the showEmployee function to pass a specific element of that array to the function to display its members. Let's go ahead and run this. Let's make sure I'm running the correct thing. And sure enough, we see our 2 employees. And so, key point to walk away from with this is once we've created our structure definition, we can treat that like a type, and because of that, we can create an array of the corresponding structures. So in the previous program, we learned that we can create an array of structures. And just as we can pass an array of characters or an array of integers to a function, we can also pass our array of structures to a function. And so let's take a look at our show staff function that's going to display all of our employees. It's receiving an array named employees that's of type struct employee. Now remember, when we pass an array to a function, we also have to pass the size or the number of elements in the array to the function, so we know how to do our loops and where our array ends and where our array begins. And so in this case, within our function, we're starting at index 0. All of our arrays are 0 index based. We're looping until we get to the employee count. It was the parameter that was passed to us that told us the array size. For each array element, we're printing out the employee ID, the employee name, the job title, the salary, the phone number. So very much like we would just loop through any element of an array, but in this case, each element of an array has multiple variables associated with it that we can get to using the dot operator. Within main, we create and initialize our array, and then we call show staff. So let's go ahead and run this program. And sure enough, we see our entire employee staff. And so just as we can create an array and pass an array of integers to a function, we can also do that with an array of structures. So we've learned that we can pass a structure variable to a function. And just like any variable, if we want to change its value within a function, we have to pass the variable by address. And so in this case, we've got our structure definition, and then we've got a function called payRaise that's going to allow us to increase an employee's salary by the amount specified. And so you can see that we're getting a pointer to our structure because we want to change the structure's value within the function. And so within the function, we use that pointer. And so note that we've got our pointer within parentheses. We want to get its address first and then take the value that's pointed to that address, the dot operator salary, and increase it by the amount that was specified. Now this may take you a minute to get used to the pointer operations in your mind a little bit, but essentially we're getting a pointer to our structure, and we're using that pointer, and then we're offsetting based on the field that we specify using the dot operator. We then have our show employee function, which hasn't changed. We're not passing a pointer to it because we don't change the structure's value in that function. And then within main, we create a variable called coder of type employee. We initialize it. We've seen all that. We then show its previous value. We then call the function payRaise to give a $25,000 raise. I want to work at that company. And to do that, we pass the address of our coder variable. You can see the ampersand coder, that's passing it by address. Once we've updated the salary amount, we want to redisplay the current fields of the employee variable. So let's go ahead and run this program. And so sure enough, we see our starting employee information. He's got a salary of $100,000, and then after we apply the raise, he's got a salary of $125,000. And so we can pass variables of type structure to a function. When we want to change any one of the members of that structure, we have to pass the variable by address, just like we would any variable that we want to change within a function. Now we've learned that when we pass a pointer to a structure, and we do that when we're trying to change the structure's value within a function, we use the pointer and the dot operator to reference the memory location of the field that we want to change. And the syntax is a little clunky. We had our parentheses, pointer, variable name, close parentheses, dot field name. And so to simplify things, C defines a way to reference a structure member passed by pointer. As you can see here, I've changed it in pay raise, and we've gone from the specific pointer look to the dash greater than symbol. And that's a standard C syntax. And so we're doing the same operation. You can see that in pay raise, we're getting a pointer that we're assigned to the worker variable of type employee. And then we're using the new syntax to get to the salary field. And so when you work with structures and pointers to structures, you may see both formats. This is the preferred format, and so nothing else has changed in our program. In main, we declare a variable called coder, initialize it. We're going to show it, then we're going to apply the pay raise, and then we're going to show it again. So when we run this program, let's see our output. Sure enough, we see our salary of $100,000 raised to $125,000. And so your key takeaway is we have a different syntax that we can use when we're working with pointers to structures to kind of simplify the pointer operation. So we don't have to think it through quite as much. We just say, I've got an address, and this is the field member within that structure that I got by address that I want to reference. And so it turns out that we've actually used this syntax in a previous program that we did where we were getting the current system time. And so to get to system time, we're going to use a struct called TM. And you can see the different fields within our structure. We've got seconds, we've got minutes, we've got hours, we have days, and so on. So it's just a structure. It's in this case, all of the variables members within the structure are of type int, but we're grouping them all together within one variable. Within our main program, we're including standard.io.h, it's defining printf. We're including time.h, we're defining a time structure. And so we're creating a pointer to that structure. And then we're declaring a variable called seconds. And so we pass the variable seconds to the time function by address. We're changing the variable of seconds value within the function, so we have to pass it by address. And then we're converting that time to local time based on our offsets and daylight savings time. And then we're outputting it. Now, our current date is a pointer to a structure. And so you can see that we're using the new syntax to get to each one of the members that's pointed to by that pointer. And so we're looking at first the month, we're looking at the day, we're looking at the year, and we're looking at the hour, we're looking at the minutes. And so if we go ahead and run this program, sure enough, we see our date and we see our time. But the key points are we're working with a pointer to a structure, and we're using the new syntax to reference members within that structure. Now, depending on the information that we want to store, there may be times when it's convenient to have multiple structures that we kind of combine together. And so we call that a nested structure. It's one structure within another structure. And so let's take a look at how we've changed our employee structure. In this case, we want to have a hire date. And so we already have a structure, TM, that contains a month, a day, and a year. And so rather than have those variables unique, we can leverage that structure. So we've nested one structure inside another. And so let's see how we're going to use that. We're still going to get to the members by using the dot operator. So let's take a look at our show employee function. You can see that we're printing the ID, the name, the title, the salary, the phone number, but then we're displaying the hire date as month, day, year. And so let's take a look at the variables that are doing that. We've got our worker variable, which is contains our structure. And so we printed worker.employee ID, worker.employee name, worker.job title. That all makes sense. But now let's look at how we treat that nested structure. And so we've got worker.hire date, but it's a structure and we want to get to its month field. So we have worker.hiredate.month. Then we want to get to the day field. So it's worker.hiredate.day. Likewise for the year, worker.hiredate.year. So let's take a look at how we initialize these. In our main program, we're creating two variables of struct employee. one a coder, one a manager. We've got our employee IDs, we've got our names, we've got our titles, we've got our salaries, we've got our phone numbers, and then we've got the date that they were hired. And so we can then call our show employee function to display all that information. And sure enough, we get all the fields. And so your takeaway on this is we can put one or more structures inside a structure definition to create a nested structure. When we do that, to get to the corresponding fields, we still just use the dot operator, but we may have to go one level deeper. So we have the worker.hiredate.month. So remember, the C programming language was created for the Unix operating system, and there was times within an operating system where you need to get down to the bits, the ones and zeros of a specific value. You've learned that C has bitwise operators, a bitwise AND, a bitwise OR, a bitwise exclusive OR. We can shift and rotate bits. But when we are leveraging bits within a value, C gives us a unique way to get to those called bit fields. And so let's take a look at how we might use them. And so remember that we're dealing with one value in memory, and we want to get to specific bit locations in there. And so in this case, we're creating a variable or a structure named date, and it's got some fields within it, a month, a day, a year. But those are actually stored in one unsigned word that has different bit locations. The day is going to be stored at the first 5 bit locations, a month the second 5, and the year the last 12 bits. And so rather than having 3 separate memory locations, we've got one unsigned word that the bits within that word are contain different values. And so we're going to use bit fields. And so you can see that within my structure definition, I have int month, and it's got 5 bits. Int day, it's going to take 5 bits, and int year is going to take 12 bits. And so I can, within main, declare a variable called today. And when I say today.month is 1, today.day is the 25th, today.year is 2021, I can then print all of those. But what's interesting is the size of today didn't take 3 different integer values, but we'll see that we stored all those within one unsigned variable. Let's go ahead and run this. And so we've got our date, and rather than having 4 bytes for the day, 4 bytes for the year, 4 bytes for the month, we're able to store all of that information using bit fields within one 4-byte unsigned integer value. And so you won't see bit fields used that often, but if you see a structure definition that's got the colon and some counts in there, you need to understand that they're looking at specific bits within that value. Depending on your application, there may be times when you want to look at memory locations that contain values in 2 different ways. And an example of that is, back in the day when we did a lot of assembly language programming in PC, we used the PC registers, which were for word values, AX, BX, CX, DX, and index registers, and the flag registers, and those were all unsigned ints. But they also had the ability to get to specific bytes within that word. And so AX had a low byte field and a high byte field, so AL and AH, and BX had a low byte field and a high byte field, and CX had a low byte field and a high byte field. So we have the ability to kind of look at them in 2 ways. We could assign a value to AX, that assigned it to the entire unsigned word, or we could assign it to the first byte or the second byte of that word. And so C provides us a way to do that called unions. You won't see them very often. And in fact, I think the only time I've used them is to write values to the registers when I was doing MS-DOS calls, so I was getting down to the low level of the machine. But in this case, we've got a union called registers. It's got a struct of word registers that are, we're going to refer to as B, and byte registers, which we're going to refer to as B. I guess the word registers we're referring to as W. And so within main, we're defining a union type registers, which is regs. And so with regs, I can assign a value to in this case, the byte register AL. And so I'm going to do that. I'm going to assign it to value 5 and print it out. And now I'm going to look at the corresponding word register, AX, and we'll see that they contain the same value. That's because we've assigned the lower byte of AX, value 5. And so we have kind of two ways of looking at the same memory locations. Let's go ahead and run this. And we can see that based on our assignment, we put the value in the same memory location. One just happens to reference it by word, one happens to reference it by byte. And so if I were to assign, in this case, I use the lower byte. If I did a AH, I'd be a higher byte. And so I can assign a value to AH without impacting my AL. But because those both map to the AX word register, it would change AX's value. And so again, you won't see unions that often, but when you do, you need to understand that it's a way to allow us to almost overlay a memory location with two different views to it. And so we've learned that as a program executes, it's going to use variables to store data. But when the program ends, that data goes away. And so to store data from one user session with the program to the next, C programs use files. In the next lesson, we're going to learn to create, read, and write files. Now, I've got a little simple example. To do that, we're going to typically do a three-step process. We're going to declare a file pointer and open our file. We're going to perform our file output or file input operations, and then we're going to close the file. And so here's code for a simple little program that declares a file pointer. And so standard.io.h defines the file in uppercase, what it is. It's a data type, and so we're declaring a pointer to it. We use the C standard library fopen routine to open a file. The R says we're opening this file in read-only mode. We're going to then read a character at a time from the file. So we've got our variable letter, which is type char. And then we're going to loop until we get to the end of the file, reading a letter from the file, writing that letter to the screen. Reading the next layer of the file, writing it to the screen. When we finally get to the end of the file, we're going to break our loop and close our file. And so that's a simple file routine. In the next lesson, we're going to learn how to write to those files, read to those files, rename those files, delete those files, and more. So your applications will really start to become functional.